Okay, our first introduction to vectors. So we have intro to vectors. Now, a vector is something that has two components to it. It has both magnitude and direction. So for example, if I say this is a 3-inch vector and the direction would be some angle. Now there's a number of different ways we can talk about this. If we were to talk from standard position, I would say this is 45 degrees from standard position. So I would have a 3, 45 degrees for my vector. Now, depending on your author, you can put the arrows on each side, and this indicates that it's not a point, that it is actually a vector. Additionally, though, we could say what degree or what direction is it from north. So if we had, for example, a compass, this one would also be, since this is 45, this is 45, but this in this case is a true heading. A true heading is from north, as on a compass, and it would be listed as 045. 045 would make it for a true north. Now, it could be something that we say quadrant measurements, and quadrant measurements are always measured to the left or right of the north-south axis. So in this case, we would say it is 45 degrees from north. 45 degrees, and it would be east of north. East of north. Now, if we had something, say, for example, in this quadrant, well, standard position might potentially be 315 degrees. Its heading would therefore be 135. You'll notice it's a 135 rather than an O because it has 100 in it, but it's from north, so that would be its true heading. Or it would be 45 degrees east of south. So we have a number of ways to talk about these. The key to a vector is it has both magnitude and direction. We've talked about the magnitude. That would be its length. Now, unlike a ray, which goes on forever and ever in one direction, a vector goes from one place to another place. The arrow simply indicates the direction of travel, the direction of motion, the direction of force. Now, because we're not creative, in any vector we have this point here where it starts. This is, of course, the initial point. And the point where it ends, of course, becomes the terminal point. So we have initial point, terminal point. We have true headings, standard position, and quadrant headings. So that's going to be off one side or the other of the north-south. Now, you can do a number of things here with your vectors. But the primary thing we're going to do is if we talk about some sort of object, and we have some force acting on it here at a particular degree, and we have some other force, maybe larger, maybe smaller, length indicating how much, it's acting at some other degree. The question becomes, where does the box, in our case, where is it going to go? Well, it's being pushed this way. It's also being pushed this way, so it's actually going to go some combination of the two. Finding the combination of the two is actually what becomes important in vectors. So, if we wanted to take two vectors, say we have 2 inches at 45 degrees, and we have 3 inches at 315 degrees. The question becomes, how do we label them? Well, we're going to take this and call it A, put a little arrow above it, that's vector A. This is B, put a little arrow above it, you'll notice only a one-headed arrow, and that is B. If I attempt to put them together, what I would end up doing is to find vector A plus vector B. I need to take this vector that I start with, being careful not to change its size or direction. I'm going to take this vector and I'm going to slide it here such that the tail of the second vector is at the head of the original vector. And I get this number. So I get 3 inches and again 315 degrees. Now, the nice thing here becomes, if I want to find what's the result of that, well, if I were a little guy and I started walking here, he walks up this direction and then turns and according to the next vector walks down here, the question becomes, where did he go? The answer is from the tail of the first, where it started, to the head of the last, where he ended. That's really his destination. It doesn't matter if he came up here and went all sorts of directions. He ended here. So in essence, all he accomplished was getting from here to here. It's like, for example, saying leaving Mount Zion, going to Elwyn, going to Decatur, going to Maroa, going to Oriena, and back to Long Creek. All you've really done is go from Mount Zion to Long Creek. In the same way, you may have a circuitous path, but all that really happened was the result of the answer. We'll talk a little bit more about this in the next one.